chapter is more on concepts lang talaga, no? So we will strengthen the concepts and we will relate how the bonding concepts, no? How yung concepts ng chemical bonding ay nakaka-affect sa behavior ng matter natin, no? So paano naka-apekto yung bonds sa itsura ng matter natin as a whole, no? Okay? So I believe it's already discussed to you in your senior high school, especially if STEM kayo, no? Pero if hindi kayo STEM, no? So, ayan siya, no? So, I'm sure medyo familiar kayo because ako nagturo akong physical science and medyo nadaanan naman namin ito, no? Yung concept lang. Okay? So, hopefully, maalala niyo yung mga previously taught topics natin, no? So, our topic for today, and this will be the final topic for the examination, which is the intermolecular forces, liquids and solids. So, okay. So, let's proceed now. So, bago tayo mag-proceed with the intermolecular forces of matter, ano muna yung behavior ng matter natin, no? So, generally speaking, our matter can be seen as solids, liquids, and gases, no? So, ganito yung typical demonstration niya when we were in elementary, no? Even until college, ganito pa rin yung uh, general representation for the different types of matter, no? So, for solids, yung ating particles ay clumped together, no? So, magkakasama sila. However, for liquids, there is a small separation between the particles, no? But not that much, no? For gases, the particles are away talaga from each other. So they are spread out, no, in the entirety of the container, no. So this is our solids, ito yung liquids, ito yung gases, no. Pero ito yung question. Bakit kaya may certain distances sila, no? Why are the particles of solids ay dikit-dikit while gases are separated, no? So kalat-kalat yung gases samantalang yung solid dikit-dikit, no? Bakit kaya, no? Okay, so yun yung i-investigahan natin ngayon, no? So we will investigate on why matter, no? Why chemical substances behaves as solids, liquids, or gases, no? Okay? So bago tayo mag-proceed doon, let's check on the properties of matter muna, no? By the way, all the materials here are already uploaded in the discussions page, no, sa Canvas nyo. So just go to discussions, check chapter 5, i-download nyo po yung mga materials doon. Ayun yung ginagamit ko ngayon. Okay? So anyway, going back na. So let's investigate on solid, liquid, and gases and maybe we can infer an idea bakit sila ganun, no? Bakit yung particles dikit-dikit, bakit yung particles hiwa-hiwalay na. Okay. So for solids, liquid, and gases, the involved particles are of course the same lang naman, no? So we are pertaining to atoms or molecules na magkakasama. Okay. So, how about the energy and the movement of particles, no? So, sabi dito, for solids, yung energy ng particles ay low. And their movement is just fixed via vibration lang, no? So, nagva-vibrate lang yung solid particles natin. And low in energy sila. However, for liquids, the particles have more energy. Teka lang. Okay, so for liquids, yung particles, they possess more energy than solids, no? And yun, the particles can flow, no? And for gases naman, the particles have high energy. So they are always constantly moving, no? So ano ibig sabihin nun, no? So imagine your eyes, no? So yung eyes ay solid, 'di ba? What happens kapag iniwan mo yan in the usual room temperature? Kunwari, iniwan mo yan sa labas ng ref, no? What will happen is that the ice will melt, no? So, matutunaw yung ice. So, kumbaga, there is a transition from solid to liquid, no? So, there is a phase change, no? So, ang question ay bakit, no? Maybe it has something to do with the energy, no? So, the phase changes has something to do with energies, no? Because if you just increase the energy of your substance, then you can move the particles, no, in such way na pwede siya maging from solid, pwede siya maging liquid, no? The same concept is true when you boil water, no? What happens when you boil water? No, after reaching 100 degrees Celsius, magbabubbles yon, and then you will see steam of gases, no? So ibig sabihin, when you add energy to your substance, then you are making the particles more excited, no? So as the particles get more excited, they will transition from solid to liquid, then to gas, no? So by increasing the temperature, by applying energy, by applying heat, that means the particles will be more energetic, no? So madadagdagan sila ng energy kapag ininit mo, no? So what will happen is that they will transition from solid to liquid, then to gas, no? So yun yung reason bakit may evaporation, bakit may melting, no? Punta naman tayo sa kabaliktaran, no? So for example, you have your water, you place it in the refrigerator. What happens, no? What happens is that yung particles ninyo, they are losing the energy, no? As the energy gets absorbed by the environment, no? Kasi kapag malamig, hinihigop yung energy mo no, no? Kapag malamig sa paligid, no? So that's according to thermodynamics, if you could remember, no? Sa high school niya. Okay, so anyway, so ang kwento, if you place your water in the freezer, what happens is that the surroundings, no, the freezer will absorb the energy of your particles. No? So as the energy is being lost by the particle, what happens is that that particle will start to slow down. No? And what happens when the particles have low energy, they will transition to be solids na. No? Okay, so ganun lang yung idea. No? So if you add energy, ang transition ay solid liquid to gas. If you get that energy, if you absorb that energy, or kunwari yung particles na bawasan ng energy, they will transition from gas, liquid, then solids. No? So nangyayari rin to in our atmosphere. No? For example, yung clouds. No? So yung clouds, that is just a gas. No? Gas of water vapor. No? However, since the temperature in above the Earth's atmosphere is low, mababa yung temperature doon, what happens is that yung water vapor, they will condense into liquid, no? Ito yung nagiging ulan, no? If the liquid on the clouds ay heavy enough, no? Magfo-fall yun as rain, no? However, kapag super lamig talaga, kunwari nasa North Pole ka, yung liquid particles ng water molecules ay magiging solid, magiging ice, no? Or snow, no? So, yun yung concept lang, no? When it comes to energy, no? If you increase the energy, the particles will start to separate, no? So, ganito lang nangyari, no? So, if you increase the energy here, no? Pag tinaas mo yung temperature, what will happen is that your particles will move, no? So, gagalaw-galaw sila. So, they will transition from fixed solid papunta sa liquid, which is kind of flexible. Pwede sila gumalaw-galaw dyan. Then, if you increase further the temperature, then yung ating particles, they will have more energy. So, ano meaning nun? Mas magiging malikot sila. Hence, they will all separate na. Separate na sila sa isa't isa. So, we will have gases na. No? So, yun lang yung concept ng phase changes. No? So, it has something to do with energy then. No? Okay. So the question is ganito, no? Balik ulit tayo sa original question. Bakit, no? Why are solids compact, no? Yung mga particles nila ay dikit-dikit, no? Bakit yan sa gases hindi, no? Okay. So nasagot na natin bakit sila nagkakaroon ng transition, no? So bakit may transition? Because of the energy. Ang question dito uli, no? Another question is ganito. Bakit kapag solids, your particles are close together while your gases are not, no? Hindi sila close together, no? Ito close together. So, the answer there is this one, no? So, it has something to do with the attraction, no? So imagine that as this, no. So if yung particles, no, kunwari dalawa kayong tao, attracted kayo sa isa't isa, what will happen? You will come closer together, no. So it means that the more attraction the particles have to each other, no, that means mas closer together sila, no. So kumbaga sa kanta nga, inch by inch we're moving closer. So ganun din yung particles, no. The more they are attracted to the other particle, they will come closer, no. Magsasama sila. Hence they will form the solid picture, no. So magdidikit-dikit sila. So ibig sabihin, the reason why solids are clumped together is that attracted sila to one another, no. Malakas yung attraction nila, no. Kaya nga sabi nila sa friends, no, kapag magkakaibigan daw, solid kapag mataas yung pag close kayong mga magkakaibigan, sabi nila doon, 'di ba? Solid yung friendship nyo, no. Kasi based on intermolecular forces, solid talaga kapag mataas ang forces of attraction. Pag malakas yung attraction nyo to one another, solid 'yon. Pero paano kapag ano, pag hindi kayo close to one another? Siyempre, pag hindi nyo close yung isang tao, lalayuan nyo. So, magiging gas kayo or medyo liquid, no? So, kumbaga, ang solid, ito yung super close friend nyo, mga BFF nyo. Yung liquid, ito yung mga acquaintance lang, no? You can get along with, pero not that close, no? Tapos yung gases, ito yung mga frenemies nyo, no? So, the ranking of the attraction varies, no? So kapag solid, malakas yung attraction nyo sa isa't isa. For liquid, not that much, no? Tolerable lang. Pero pag gases, mababa yung attraction nyo, no? So yun yung ano concept, no? So ibig sabihin that the phases of matter can be caused by number one, energy changes, no? So if you induce energy, pag nagdagdag ka ng energy or nagbawas ka ng energy, nagbabago yung phases of matter, no? As you give energy to your substance, they become more energetic, they will separate, no? Pag binawasan mo yan ng energy, they will come closer together, no? The second factor that affects the phase of the matter is the forces of attraction, no? So ano yung forces of attraction? It just tells you that if the attraction is strong, then the particles will come closer together, no? And the closer they get, they become liquids or solids, no? Pero if they are not that attracted to each other, meaning hindi sila good as friends talaga, then most likely you will observe gases, no? Okay, so kumbaga may dalawa na kayong idea ngayon, no? So energy affects the phase of the matter, no? Higher energy going to gases, no? Lower energy going to solids, no? The second factor that affects the phase of the matter is the forces of attraction. The more attracted they are, the more likely na solid yon or liquid na. Pero kapag hindi sila attracted, most likely sila ay gases na. Gas sila. Hindi sila talo as friends na. So, yun lang yung concept ng matter, no? And that's the kinetic molecular model of the matter, no? So, ganyan yung concept, no, ng matter natin, no? So, yun. So ngayon, punta tayo sa forces of attraction. No? Kasi we are done with the energy. No? Last time pa yun eh. No? Chapter 1 pa yun, if you could still remember. But anyway, so this time, we will now focus on the forces of attraction. What makes the particle close and what keeps them apart. No? So, punta tayo doon. So for forces of attraction, we have two types of it. No? We have the intramolecular forces and the intermolecular forces, no? So observe the subtle difference, no? Intra, inter. Ano naman? Okay, ganito, no? Intra. Saan kayo nakakarinig ng intra? Most likely, intramuros, no? So what is intramuros, no? Yun yung nasa Manila, no? Hindi. Ang literal translation yon in English is that city behind walls, no? Or behind walls, no? Or inside the wall, no? Bakit, no? Kasi ang meaning ng intra means inside, no? Ang muros ay wall in Spanish, no? So intramuros, within walls, no? Or city within the wall, no? Okay. So ang intramolecular forces naman, so when we say intra, these are the attraction inside the molecule, no? So sila yung forces of attraction within a molecule, no? So ano ba meron sa molecule? You have different atoms, no? And the way the atoms are connected to each other, yun ang intramolecular force, no? So yun yung nagkikip sa kanila para magsama sila. Okay? So saan po ba natin makikita yung intramolecular forces? What are the forces that hold the atoms together? Dalawa lang yan. You can have ionic bond and covalent bond, no? So ibig sabihin, if we are pertaining to intramolecular forces, we are just we're just focused kung sino yung ionic bond at sino yung covalent bond, no? So yun lang yan, no? So sila yung forces of attraction that holds the atoms of a molecule together, no? So chemical bonds lang yan, no? Yun na yung pinaka ideal dyan. So intramolecular forces, chemical bonds, no? Intermolecular forces, ayan, inter, no? So parang internet, no? Ano meron sa internet? Network of networks, no? So may network na isa, may network sa kabila, pinag-connect yung network nila. So you have internet na. So ganun din naman dito sa molecules natin. We have the intermolecular forces, no? So from the word inter, that means one molecule to the other molecule, no? So iba't ibang molecule naman yung may attraction. Okay? So kumbaga, intramolecular forces, attraction within the molecule. Intermolecular forces, attraction between molecules, between different molecules. So to visualize that, ito yung ating HCl molecules. We have 3 HCl molecules here. The bond that connects hydrogen and Cl, that is the intramolecular force, no? Or the intramolecular attraction. Yun yung chemical bond, no? But the attraction of one molecule to the other molecule, we call that the intermolecular attraction. Okay? So, yun lang. So, before we proceed with that, no, reviewin natin yung intramolecular forces natin. Ano yung iba't ibang uri ng chemical bonds natin, no? Okay, so let's have some examples here. So, types of intramolecular forces. Number 1, ionic bonds, no? So, what happens with ionic particles, no? Bakit sila nagiging ionic particle? Because they want to get stable, no? Gusto nila maging stable in such way that they will release and accept electrons, no? May atoms na magre-release ng electron and may atoms na mag-accept ng electron. And as they do so, they change their charges, no? So, if the atom loses electron, its charge becomes positive. If the atom gains electrons, its charge become negative, no? So, for example, we have NaCl. Na is a metal. Cl is a non-metal, no? So, what will happen is that since sodium is metal, it tends to give off the electron because metal do not like electrons, no? Ayaw nila yan masyado. So, ipapamigay nila yan papunta sa non-metals, no? Non-metals love the electrons. So, as it happens, as the transfer of electron happens, we have charged particles, no? So, may charged particles na tayo. Sodium becomes a cation, chloride becomes an anion, no? So, the attraction between positive and negative charge, no, forms our ionic bonds, no? So, ano uli yung force that holds them together? That's electrostatic forces, no? Ay. So, yun lang. Yun lang yung concept dyan, no? Electrostatic. Okay, so ano nangyari, no? So, once our atom loses or gains electrons, we will have charged particles, no? We have positive charged particles and negatively charged particles. So, they will be attracted to each other according to electrostatic forces, no? Ano yan, sir? Ano, meaning lang yan, positive attracted sa negative, no? So, yun lang. So whenever there is an electrostatic forces, then we have ionic bond, no? So yun lang yung isang intramolecular force of attraction, ionic bond, no? So proceed tayo with the next one. So we now have covalent bond, no? So ano meron sa covalent bond, no? So there is a sharing of electron. Bakit sinashare yung electron? Because I told you last time that electrons are shared because walang gusto magbigay, no? So ang usual example dito is non-metals, 'di ba? For example, you're going to make oxygen gas, no? So paano 'yon? May dalawa kang oxygen molecule. No one will give off electrons. They love to accept electrons, eh. So what will happen is that they will compromise. So they will come to an agreement na mag-share na lang sila ng electrons, forming the covalent bond, no? Okay. So alam din natin na maraming uri ng covalent bond na. So depending on the electronegativity, you can have different types of covalent bond, no? One of which is the nonpolar covalent bond, no? So ano meron sa nonpolar covalent bond, no? You have atoms of similar electronegativities, no? So the electronegativity difference is usually less than 0.4, no? Pero dito 0.5, no? Anyway, usual textbook issues, no? So yung textbooks kasi depende sa context, eh. But anyway, so that's the idea, no? So for non-covalent molecules or non-polar covalent bonds, no, the electronegativities are similar, no? No. So ibig sabihin mababa lang yung difference, usually up to 0.4 ang difference, no. So one example is the ClCl, no. The electronegativity of Cl is 3.0 to 3.0 din. So i-subtract mo yon, 3.0 minus 3.0, 0 yung sagot, no. So if 0 yung electronegativity difference, that means yun ay non-polar covalent bond, no. Okay? So yun lang. Sana naalala nyo habang sinasabi ko, no. Okay. So the next type of covalent bond is the polar covalent bond, no. So this happens when the electronegativity is slightly higher, no. So may slight difference na sa electronegativities, no. So what's the range, no? So according sa textbook na ginamit natin, that's 0.4 to 1.8, no? Itong textbook na to, 0.5 to 1.9, okay lang yan, no? Tolerable lang yung difference na yan. Small lang naman, eh. Okay. So ano ba nangyayari when we have a slightly different electronegativities? Okay. So ano ba mo... Teka lang. Kala ko naman kung ano. Okay, so ano ba muna yung concept ng electronegativity, di ba? So if you could still remember, electronegativity is the tendency of an atom to pull the electrons, no? So ibig sabihin nun, the greater the electronegativity difference, no? Mas malaki yung difference ng dalawang atoms, then there is now an unbalanced distribution of electron. Hindi na balanse yung distribution ng electron. Bakit, no? Kasi may isang atom na nanghihila ng mga electrons, no? That atom will pull all the electrons, no? So let's have an example, H and Cl, no? So hydrogen, that has an electronegativity of 2.1. So that's 2.1 for hydrogen. Chlorine is 3.0. So kunin mo yung difference niyan, that's 0.9, no? So the 0.9 electronegativity difference corresponds to a polar covalent bond, no? What happens here is that, 'di ba ito yung mga electrons, no? Remember that the more electronegative atom will pull the electrons. So in this case, chlorine yun, no? So chlorine will pull all the electrons. So hihilahin niya lahat ng electron. So as the electron goes to the side of chlorine, so andito na yung mga electrons, no? What will happen is that the electrons will be concentrated on one side, no? So magkakaroon ka ng concentration ng electrons on one side only. Hindi na siya kalat, nasa isang side lang. So as the electrons joins together, nagsasama-sama sila sa isang side, you can now create partial charges, no? Kakaroon ka ng partial charge kapag ganun. So, ano ulit nangyari? Since the electrons are confined in one space, nandun lang sila sa isang side ng molecule, yung side ng molecule with more electrons, siya ay magkakaroon ng partial negative charge. No? Partial, bakit? No? There's a chemical bond pa rin naman kasi. No? May chemical bond dyan. Partial, meaning nun. Bakit negative? Because electrons are negatively charged particles. So, kung nasan yung electron, andun yung negative. No? So, nasa chlorine yung electron. So, andun yung negative na charge, pero partial na. Because of the covalent covalent bond na. Okay? So, Cl will have the partial negative charge. Hydrogen will have the partial positive charge naman. Bakit, no? In lack of electron, pag kinulang ka ng electron, magiging positive ka na. Kasi again, keep in mind, electrons are negative, no? So, kapag walang electron, positive yon. Kapag andun yung electron, negative yon na. Partial positive, partial negative na. So, for a polar covalent bond, we create what's called the dipoles, no? So, meron tayong dipoles dito. Di, dalawa, pole, ends, no? May dalawang ends, no? So, may positive end, may negative end, no? So, whenever we have a polar covalent bond, we have dipole molecules or dipole bonds, no? So, yun lang yung concept dyan. Okay? So, that's for covalent bond, no? So, covalent bond is the sharing of electrons. Depending on the electronegativity difference, you can have two types of it, no? First one is the nonpolar covalent bond, wherein your electronegativity difference is slightly similar na. So, hindi ganun kalaki. Usually less than 0.4 na. So, pag lumaki naman yung electronegativity difference nyo, you have a polar covalent bond. So, medyo different na yung electronegativity. So, whenever you have a different electronegativity case, no? Magkaiba na yung kanilang electronegativity talaga, you create dipoles, no? Wherein the atom that bears the highest electronegativity will become the partial negative end, and the atom with the least electronegativity number that bears the partial positive end, no? So, yan. Kung nasan mataas yung electronegativity, andun yung partial negative. Kung nasan mababa, andun yung partial positive, no? So, you have a dipole. May positive end ka, may negative end ka, no? So, the next one is metallic bonding, no? Bakit, no? Ano tong metallic bonding? Kasi without this, yung metals, they will not exist, no? Saan tayo nakakita ng metal, no? So, in laptops natin, cellphone devices natin, no? Itong microphone stand ko, they are all made of metals, no? Ano ba yung tendency ng metals, no? Tendency of metal is that they will give electrons, no? So, para silang ano, no? Parang non-metal. Counterpart lang, no? Kasi ang non-metals, they love electrons. So, they will hold the electrons, no? So, yung metal naman, they don't like electrons. So, they will give it off, no? Pero paano sila nag-e-exist, no? So, paano nag-e-exist yung metal? For example, yung aluminum sa bubong, no? Paano kaya yun, no? So, ganito lang, no? Metals do the same thing as non-metals, no? They also form covalent bond, no? Pero since metal sila, ang tawag sa covalent bonding nila ay metallic bonding, no? Okay, so hindi na siya covalent bond lang. Ang tawag sa kanya ay metallic bonding. Why? This is only present in atoms of metal, no? So kapag may metal ka lang, dun lang nag-e-exist ang metallic bonding. So what's the concept here, no? Remember that electrons are being being given off by metals, diba? True naman yun, no? So, pinapamigay ng ating atoms yung electrons kasi metal sila, ayaw nila, no? So, ganun yung gagawin ng lahat ng metals na yan, no? Kasi ipapamigay nila yung electrons na yan, no? So, what will happen here is that you have your metal atoms here and then around them are the electrons they want to give off, no? Ito yung mga electrons na pinapamigay nila, no? So the electrons that they don't like, no, yung pinapamigay nila, they create what's called the sea of electrons, no, or the mobile valence electrons, no. So this sea of electrons actually hold them together, no. So yung pinapamigay nilang electron, yun yung reason why they are clumping together as solid chunks of metal, no. So yun lang yung idea dito. So the sea of electron actually holds the atoms together, no. So yan yung metallic bonding, ganun lang yung concept niya, no. So kumbaga para itong para siyang sharing of electrons din, no. Para rin siyang covalent bond, no. Ang special case lang dito ay metal yung present, no. Okay, so ganun lang ginagawa nila. Yung kanilang valence electrons, the electrons they want to give off, they are being transformed into sea of electrons, no? Sea of mobile electrons, no? Okay. And that sea of electron holds them together. And that's also the reason why metals are conductive. Bakit conductive? Ang idea lang naman kasi ng electricity is that the electrons can pass through, no? Since ito ay dagat ng electron, ibig sabihin, yung electron pwede tumagos papunta from one end to the other end, no? So may conduction, hence may kuryenteng nata-transfer, no? So yun yung reason why metals are conductors. Yung non-metals, they are not conductors. Bakit? Kasi sila ay nag-absorb ng electron. Ayaw nila mamigay. Gusto nila tumanggap, no? Okay, so non-metals, non-conductors, metals, conductors, na. Okay. Anyway, punta naman tayo dito, no. So let's go to the relative strength of the intermolecular forces, no. Intramolecular. So ito yung ranking ng intramolecular forces based on the strength, no. So metallic is the highest, nonpolar covalent is the weakest, no. Okay, so ano yung basis natin dito, sir? No? So usually the basis is yung temperature, no? Temperature kung saan magkakaroon ng phase change, no? So for example, if you want your metals such as iron, okay, so yung iron, para siya ay mag-melt, no? Hanapin natin sa Google. So the melting point of iron is 1,500 degrees Celsius. No? So it requires that much energy. So the solid particles will separate. No? Okay? So ibig sabihin nun, if mataas na energy ang kailangan for your solid particles to separate into liquid, then the attraction is super high. No? Masyado silang close. No? Okay? So masyado silang malakas. No? So that's for metallic bond. Yun yung reason bakit siya yung strongest of all the intramolecular forces. No? Kasi masyadong mataas yung attraction nila from one another. No? Okay, ito yung basis of formation. No? Yung sea of electrons nga. So experimentally speaking, metallic bond is the strongest. No? It requires higher temperature para mag-separate yung particles, no? From solid to liquid, then liquid to gas, no? So, ganun. Masyadong mataas yung energy required para paghiwalayan yung particles, no? So, let's have the next one, ionic bond, no? Ionic bond ranks the second, no? Bakit, no? Let's have an example. Sodium chloride, no? Melting point. So the melting point of sodium chloride is just 801. No? 801. So lagay tayong example. Iron metal, 1,500 degrees Celsius. Masyado mataas yung energy required. So the particles will separate. No? For ionic bond naman, NaCl, that's just 850 degrees Celsius. Ay hindi, 800 lang pala. 801 actually. So, masyadong mababa yung energy required for the particles to separate pag ionic bond, no? So, medyo mahina kasi yung attraction as compared to metallic, no? Okay, next one, we have polar covalent bond, no? So, let's have H2O. So, kailan nagme-melt yung water? 0 degrees Celsius, no? So, masyadong mababa compared to ionic bond and metallic bond, no? So, yun. So, third strongest ang polar covalent bond, no? Based on experimental basis, no? Then, non-polar covalent bond, no? Ang example ko dyan usually ay methane, no? So, the melting point of methane, no, CH4, is negative 182 degrees Celsius, no? So, ibig sabihin, onting energy lang, magme-melt na yan, no? Samantalang yung metallic bond, masyadong maraming energy ang required para mag-melt siya, no? So, yan. So, depending on the strength of the intramolecular force, the melting point, no, or the temperature at which your matter will transition from solid to liquid ay magbabago, no? So, ito lang yung sinasabi kong concept kanina, no? So, the stronger your forces of attraction, that means more energy ang kailangan for them to be separated, no? So, more energy translates to higher temperature, no? So, yun lang yung concept, no? So, ano uli yung ranking? So, we have the first one, the strongest type of intramolecular force, metallic bond. Second is the ionic bond. Third is the polar covalent. And fourth is the non-polar covalent, no? So, yan yung mga strengths nila, no? So, based on the strength of the forces of attraction, you can now predict kung solid siya, liquid siya, or gas siya, no? So, kapag metals yan, matic, solid yan. Kasi you know na, alam nyo na ngayon that their melting point is way higher, no? Masyadong mataas yung melting point nila. Although may exemption dyan. Ano yung exemption? Number 1 is gallium. Number 2 is mercury. Yung gallium, nagme-melt siya sa kamay. Yung mercury, liquid talaga siya, no? Well, for that case, no, I don't know the reason, no? Kasi usually, sila yung ina-exempt pa, no? So, yun. So, hindi ako nagbasa ng articles about them, no? Pero usually understood na sila yung exemption sa rule parate, no? Na sila yung may mahinang metallic bond, so they exist as liquids instead of solids, no? But this is true for the rest, no, of the metals that we have, no? Sodium man yan, potassium metal man yan, calcium man yan, no? Iron man yan, so on and so forth, no? So true naman to for most except for gallium and mercury, no? Sila lang kasi mga liquids, no, under low temperatures, no? So yung mercury liquid talaga yan, yung gallium, natutunaw yan sa kamay, no? Anyway, so the next strongest, ionic bond, polar covalent, and non-polar covalent, no? Usually, yung non-polar covalent molecules natin, they exist as gases, no? Ito, gases to usually. Ang polar, usually liquid yan, or gas, pero mostly liquid. For example, water. Then, itong mga ionic and metallic, no? Sila ay mga solid, no? So, solid tong dalawa. Ito ay mga liquid, then ito ay usually gases, no? So, yun. By just identifying the type of bonds, you can predict the phase of matter niya, no? So, alam niyo na yung phase of matter niya. So, just look at the chemical bonds, no? Para may sagot kayo. Okay? So, ganun lang. By the way, bago ako mag-proceed sa inter, no? Baka isipin nyo, sir, pag nilagay ko naman yung ionic bond, no? Pag nilagay ko naman yung asin sa water, natutunaw siya. Mali yun. Hindi siya natutunaw, no? It ionizes, no? Iba yung process ng melting sa ionization. Ano ba yung nangyayari sa ionization? Remember chapter 4. Ionization process is where your cations and anions separate, no? Into ions, no? Aqueous solution yon, no? So, iba yung ionization sa melting. So, ano yung ionization? Maghihiwala yung particles pero nasa tubig. Ang melting, maghihiwala yung particles kahit walang tubig. Okay? So, walang tubig na usapan dito, no? Kaya kapag nilagay niyo yung asin sa tubig, matutunaw yon kasi ionization process yon. Hindi yon melting, ha? Okay? So, yan. Just to clarify, no? Kasi baka mamaya ma-confuse kayo. 801 degrees Celsius yun. Ay, nilagay ko yan kanina sa tubig eh. Natunaw agad, no? So, hindi yan. Ionization yung tawag doon. No? Okay? So, yun lang. So that's the intramolecular forces, no. Do you have to remember this, no? Of course, be familiar lang. In-upload ko naman yung lecture guide sa Canvas, no. Download nyo na lang, no. Ganito rin yung makikita nyo doon. You may want to read the lecture guide more para mas maraming idea, no. Kasi ang pinapresent ko ay general lang, no. Okay, so let's now proceed with the intermolecular. Bigyan ko ng emphasis, inter. Ibig sabihin yan, one molecule to the other molecule. Intermolecular forces. Okay. So, intermolecular forces are generally weaker than intramolecular forces. But they are important nga in determining the physical properties of matter as well. So, same sila ng significance as the intramolecular, no? Pero, keep in mind that siya ay weaker than the intra, no? Okay. So, ano ba yung iba't ibang uri ng intermolecular forces, no? Ano yung reason bakit magkakasama ang mga iba't ibang molecule? So, we have three types of intermolecular forces. Number one is the dipole-dipole interaction. So, ito yung isang uri ng intermolecular force. Dipole-dipole interaction. From the word itself, ano meron dyan? You have a dipole and another dipole. Ganun lang. So, that means you have polar covalent bonds here. Okay? So, ano na nangyayari with dipole-dipole interaction? So, tingin tayo dito sa picture. So you have a dipole molecule and another dipole molecule. The interaction between those molecules is what's called the dipole-dipole attraction or the dipole-dipole interaction. So, paano nag-interact yung one molecule and the other molecule? Okay, remember that for a dipole molecule, you have your charges. Yung chlorine dito, that will be partial negative. Yung hydrogen will be partial positive. That is true for all the dipole molecules we have here. So itong HCl, negative parati yung Cl. Itong H, positive siya parati. Okay. So ano ngayon? ano alam natin? Positives are attracted to negatives. So that means this molecule can be attracted to this molecule via the negative end. Ito naman, this molecule can be attracted to that molecule as well via the negative end naman. So, bakit may attraction? Kasi remember, negative yung end na tong molecule na to. We have a positive end for this molecule. Hence, there will be an interaction. Positive is attracted to negative, so magsasama sila. Positive attracted sa negative. So, pwede silang magdikit, So, magtatabi-tabi lang sila, And that, yung tabi-tabi ng molecules, that's what we call the dipole-dipole attraction, or the dipole-dipole interaction. So, again, ano yung concept ng dipole-dipole interaction? The concept is just the positive end of one molecule is attracted to the negative end of the other molecule, So, yun lang yung kailangan nyo isipin. May dipole ka, yung positive, ma-attract sa negative. This attraction is the dipole-dipole interaction. Okay? So, ganun lang. Dipole-dipole interaction. So, yun lang. Ganun lang po. Next one, hydrogen bonding. So, ano naman meron sa hydrogen bonding na? So, hydrogen bonding is a special kind of dipole-dipole interaction. So, special siya. Bakit? This can only be observed when a hydrogen atom is bonded with oxygen, nitrogen, or fluorine atoms. So, makikita lang po ito if we have OH bond, NH bond, and FH bond. So, dyan lang po yan nakikita. Wala na sa iba. So, ibig sabihin itong HCl na to, hindi yan hydrogen bonding. Dipole lang yan. But the OH is a dipole and also a hydrogen bond. So, ano lang yan? All dipoles, all hydrogen bonds pala ay dipole. But not all dipole are hydrogen bonds. So, hindi lahat ng dipole ay hydrogen bond. Bakit? Specific lang to sa tatlong bonds na to. Itong OH, NH, and FH, no? And this is also the reason, no? Ito yung sinasabi ng mga scientists, no? Mga evolutionary scientists, no? This is the reason why we exist on Earth, no? Why life is possible on Earth, no? Kasi usually, dipole molecules have low boiling point, no? An example niyan, one example of dipole molecule na mababa ang boiling point ay si itong HCl. So HCl usually boils at around 80 plus degrees Celsius, no? So magbo-boil agad 'yan. Remember na yung Earth, no, during the old age, may mga volcanoes, no? So masyadong mainit, no? So it means kunwari 80 degrees Celsius yung surface temperature ng Earth, no? Kunwari HCl yung water natin that time, no? Lahat yun nag-boil off, no? Lahat yun nag-evaporate, no? So pangit yun. Kasi hindi mabubuo yung primordial soup, no? Kasi sabi nila, sabi ng mga evolutionary scientists natin, the primordial soup is the reason why we exist, no? Doon nagsama-sama yung mga nucleic acids, no, to form cells, no, and eventually to form life on Earth, no. Okay. However, due to hydrogen bonding of water, ito yung OH bond, may hydrogen bonding dyan, no. Okay? So parang dipole lang din siya, no, yung positive attracted sa negative, no. Pero special to kasi ito yung strongest na dipole, no. Okay. Strongest dipole. And dahil nga daw dyan, dahil siya ay strongest dipole, so that means yung water, it would have more strength, mas strengthened yung nila, interactions, mas malakas yung kapit nila to one another, hence they will not easily boil off, no? Hindi sila agad-agad mag-evaporate, no? So yun, so kahit na puro volcanoes here on Earth, no, yung primordial soup is possible, no? Kaya whenever scientists, especially mga NASA scientists, whenever they find a planet na may water, usually they think of life, no? Possible ba yung life dito? So on and so forth. Yun yung reason, no? So, in-explain ko na sa inyo kasi baka nagtataka kayo, no? Uy, may tubig lang naman. Ano naman meron? Kasi yun yung reason bakit tayo nag-exist ngayon according to evolution, no? So, yun. Whenever there is water, there is a possibility na magkaroon ng life forms, no? Ibig sabihin kasi, wherever hydrogen bond is, andoon ang life, no? So, yung OH, nakikita yan sa water. NH, ano to? Usually sa mga ammonia, even in our nucleic acids, no? So, yung ating nucleic acids, they're composed of nucleotides, no? Ano meron sa mga nucleotides na yon? Yung mga base pairs natin, di ba? So, yung ACGT. So, yung mga ACGT na yon, they are paired with hydrogen bonding. And yung ACGT, that corresponds to life, no? Meron tayo nun. So, ibig sabihin nun, wherever andun yung hydrogen bonding, possible na may life doon, no? So, possible na may mga DNA doon, possible na may mga RNA. That's why, yung scientists natin, whenever they find water in this planet, na-excite sila, no? Kasi possible na may buhay nga doon. Such as sa Mars, no? Baka may evolution, baka may mga nangyari sa Mars, no, na ginawa na ng mga tao doon dati. So, malay mo lang, hindi natin sure. Okay, so yun lang, share ko lang. Pahaba yung kwento. So let's have the last one, no, the London Dispersion Forces, no. Okay, so London Dispersion Forces, this is just, ba yan? This is the weakest intermolecular forces of attraction, no? And this exists between all types of molecules, no? Lahat. Okay? So, kumbaga, London Dispersion Forces or the Van der Waals forces, ito yung general force of attraction. Lahat ng bagay sa Earth, meron nito. Okay, so kumbaga kung lahat meron yan, ibig sabihin yan ay generic, no? Kapag generic, medyo mababa yung force, no? Medyo mababa yung quality niyan. Not all naman, no? Pero that is true for these molecules, no? So generic type of bonding to, no? Generic type of intermolecular force. So ibig sabihin medyo mababa to, no? mababa yung specs, no? Or mababa yung quality niya, no? So, para siya yung mga OEM na device, no? So, yun. Medyo mababa yung quality ng OEM daw kasi, sabi nila. So, ganun nga rin dito, no? So, ano meron dito sa London Dispersion Forces? So, ito yung weakest intermolecular force and ang kino-consider lang natin doon ay yung electrons, no? Ay, bakit doon? Ang kino-consider lang natin dyan ay electrons. Sabi dito, the more molecule your atoms possess, the higher or the stronger the London dispersion forces is. No? So, yun lang yung keep in mind natin. No? So, more electron, higher London dispersion forces. No? Or dispersion forces. No? So, kuha ko ng example ha. Punta ako dito sa PowerPoint. Okay, so let's have this for example. No? So, mapapansin natin that the melting point increases. So, ibig sabihin, the strength of intermolecular forces increases. No? So, ito yung mga chemical compounds natin. So, sabi natin, by default, lahat yan ay may London dispersion forces. Yes po, lahat to merong London dispersion forces. Tignan natin kung true yung fact na more electrons equal higher strength ng intermolecular force na. So makikita naman natin, 'di ba? More electron, ibig sabihin ng mas mataas ang attraction. So kapag mataas yung attraction, the higher the melting point will be or the higher the boiling point will be, no? So tignan natin how many electrons do we have for carbon and hydrogen, no? So carbon is in group 6, yung atomic number ni carbon ay 6. So ibig sabihin nun may 6 yung electron by default. Si hydrogen may isang electron times 4, no? Kasi 4 yung ating hydrogen atoms. So may 10 electron for CH4. Let's try CF4, no? So 6 plus ilang electron si fluorine? 9, no? 9 yung atomic number niya. Hindi valence electron, ha? I'm pertaining to the electrons in total. Okay? So that's 9 plus 4, 9, 18, 27, 36 plus, tama ba yung math ko? Kakalkyo ko na lang. 9 times 4 plus 6, 42 electrons. No? Okay, tapos tatry ko na yung nasa dulo. Carbon and iodine. No? That's 6 plus, teka lang, iodine. 53. Dami 53 times 4 plus 6. 218 electron. Okay, observe the trend, no? So sabi natin, the higher the number of electrons, the stronger the London dispersion forces. So that means the more intermolecular force, no? The stronger yung kapit nila. So let's check the melting point, no? Is that true? Totoo naman, no? Kasi tignan mo, if 10 electrons yan, negative 182. Pag 42 electrons, naging negative 150, no? So this is higher than this one, no? And of course, obviously, itong 171, ito ay higher than the rest, no? So ibig sabihin yan, the more electrons you have, the higher the dispersion forces. Ibig sabihin nun, the stronger the interaction of one atom, of one molecule to the other molecule, no? Okay, so yun lang yung kwento ng dispersion forces. Okay, so ano naman kung ganun, no? Kasi ganito yung nangyayari, no? So if you have electrons, no? Pag marami kayong electrons, sinara ko ba? Ay, hindi. So if you have many electrons kasi, what happens is that ganito, no? So let's have Cl2 ulit, no? So 'di ba usually bilog lang 'yan, no? Kunwari ganyan. Ito yung electron clouds, no? Ganito kasi, yung ating molecules naman, they frequently bump to each other, no? So nagbubungguan sila. Etong pink na circle natin, this is the electron cloud, no? So for example, at this instance, what happened, no? Nag-touch yung dalawang electron cloud, no? So nagdikit yung dalawang electron cloud. What will happen? Alam natin electrons ay negative, so they will repel. Negative to, negative yon. So, they will repel, no? So, ganito yung mangyayari, no? So, magre-repel sila, no? Mapupunta sa isang side yung electron, and ganun din dito, no? Ayan, malaki dun kunwari, no? So, what will happen is that the electron cloud will be distorted, no? Okay? So, madi-distort siya or polarized, no? Distortion of electron cloud, no? AKA, ang tawag doon ay polarizable. Polarize, no? Mapopolarize yan or madi-distort yung electron cloud, no? So, ano mangyayari whenever the electron cloud is distorted, no? Or na-polarize yung iyong electron cloud? Mapapansin nyo is that the electrons will be pushed to one side, no? Mapupunta sila dito sa isang side, no? So, ibig sabihin nun, pag andun yung electron, this will be partial negative. And yung side na walang electron, yun ay magiging partial positive, no? So, this is what we call the temporary dipole. Okay, so ano meron sa temporary dipole? That is resulted by the polarization of your electron cloud, no? Yung distortion ng electron cloud, no? So whenever the electrons are polarized or disturbed, no, or distorted, ibig sabihin nun, the electrons are shifting towards one side only. So as the electrons shift towards one side, then you create a temporary dipole. Pero from the word itself, temporary yan. Bakit? Kasi eventually, pag naghiwalay yung particles na yan, babalik sila sa spherical lang. No? So, babalik sila sa normal shape nila. So, ibig sabihin, may dipole, pero temporary. Na. So, ibig sabihin nun, yan, pansamantala lang yung force na ito. No? So, the more electrons you have, no, the greater the chances that the electrons will get polarized. No? Ibig sabihin, more yung chances na magkaroon ng more temporary dipoles. No? And when you have more temporary dipoles, the stronger your interactions will be. No? The stronger your intermolecular forces will be. No? Okay. So, yun yung reason bakit sinabi sa LDF na more electrons, higher London dispersion forces, meaning non greater strength na. Strength na. So, ganun lang yung idea niya na. So, ito yung keyword pag dispersion forces. May temporary dipole. But again, hindi lahat ng dipole ay permanent, no? In this case, temporary lang yan. So, babalik uli yan sa normal shape. So, mawawala yung dipoles, no? So, kunwari, nagbungguan uli sila, edi magkakaroon ka ng dipole, tapos mawawala uli, no? Vice versa. Okay, so temporary lang kasi ang London dispersion forces. Kaya sinabi natin ito ay weakest, no? But again, the more electron, the higher the chances for London dispersion. Hence, it will be stronger eventually, no? Pag marami ng electrons masyado. Pero pag onte, hindi, no? Okay? So, ranking the strength of the intermolecular forces, we have this, no? So, the first one will be given to hydrogen bonding. So, siya yung strongest. Okay, siya yung strongest dipole-dipole interaction, and that is just limited to HF, HN, or HO bonds. No? Okay, so this is dipole, but special. No? So, dito lang siya nakikita. The second strongest will be the dipole-dipole attraction. Okay, so yan, you have a partially charged ions, or you have partially charged molecules na. And yung kanilang interaction is quite strong na. So medyo malakas yan. Then of course, yung pinakamahina nyo, the weakest would be yung pinaka-general, no? The London dispersion forces. So the attraction is due to the temporary dipoles or induced dipoles. Okay? So, yun lang. So, keep in mind yung ranking, no? Okay. So, by the way, whenever you have hydrogen bonding and dipole-dipole, usually, you will expect water, liquid particles pala, no? You will expect na liquid siya, no? Usually, liquid sila. Pero ito, ang London dispersion forces, usually, gases yan, no? Gases. Usually. Okay, so most of the time, hydrogen bonding and dipole-dipole, sila ay mga liquids, no? Yung mga London, sila yung usually gases, no? Okay, so yun lang. So keep in mind lang yung mga, mga ranking. By the way, nandun naman yan sa PDF na in-upload ko sa discussion sa Canvas. Okay, so yun lang. Okay, so yun lang. Okay, so we're done with the intermolecular forces. Now let's proceed with the second part of our lesson. The second part of our lesson would be the liquids naman, no? Since nakwentuhan na natin yung liquids, no? Okay, so there are some liquid phenomena that is resulted by the intermolecular forces of attraction. No? So consider this water strider. Ito yung nasa movie ni Jackie Chan na The Tuxedo. No? So, hinighlight dun sa movie na yon ay bata pa ako nun. No? Grade 4 pa ata ako nun. Panood ko to. Recently lang to, no? Around 2008 ata. No? So, yan. So, ito sa movie ng The Tuxedo, in-emphasize doon yun na yung water strider, they can walk on water. And makita nyo, for example, itong picture na to, while the water strider walks on water, makita nyo yung curvature sa gilid ng water. No? So, nagka-curve yung water. No? Okay. The curvature of the water is because of the surface tension. No? So, this is one liquid phenomena, the surface tension. So, ano yung surface tension? This is just the bending of water. No? Bending of water. No? Pero if you want more specific answer, yung pinaka-correct answer talaga, ito yan, blah, blah, blah. So, ano lang yan? Measure of elastic force in the surface of water. Yun yung surface tension. So, ibig sabihin lang nun, yun yung bending of liquid. No? Okay, so bakit ba nagbe-bend ang liquid? Number one is that it wants to maximize the intermolecular force. No? Gusto niya i-maximize yung chances for it to do intermolecular forces. No? So gusto niya kumapit sa mga kasama niya or sa kapwa molecules niya. No? Okay, so magbe-bend. No? So makita natin yan usually with this example. No? So in this test tube, we have water here. H2O lang yan. And on the other side, we have mercury. Teka lang. Kailangan ko ng white. Yan. Yan. So on the left side, we have water. And on the right side, we have mercury, which is liquid na. So liquid silang dalawa. But observe, no? Yung water, it curves downwards, no? So may downward curve siya. While yung mercury, ang curve niya ay upwards, no? Ang tawag dyan ay meniscus, no? So, meniscus. So, dalawa yung uri ng meniscus natin. We have the concave meniscus and we have the convex meniscus. Ang question yan ay bakit may ganun? Bakit may concave? Bakit may convex? Ito yung reason, intermolecular forces. Paano yun yung naging sagot? Ganito. Yung glass natin, ayan ay dipole. Okay? Dipole ang glasses. No? Silicon dioxide, no? Andyan, mga dipole molecules yan. Water is a dipole molecule as well. No? May hydrogen bonding yan, pero dipole din yan. No? So, observe, no? Ang glass ay dipole, ang water ay dipole. So, ibig sabihin nun, it would be better if they will attract each other, no? So, mas okay kung magsasama sila to maximize the intermolecular forces. So, ganun yung napagkasunduan nila. Kunwari ako si water. Sabi ko, uy, si glass, dipole din. Dipole ako. Match yun. So, didikit ako sa kanya, no? So, whenever the liquid attaches to the next material, to the glass, ang nangyayari is that magkakaroon siya ng concave meniscus. No? So, magka-curve siya ng paganyan. No? So, paano yung nagiging concave meniscus? No? So, ganito. Imagine nyo, ito yung glass. Ito yung water. Flat. No? Ito glass. No? Sabi ni water, uy, parehas tayong dipole. So, magsama tayo. So, ano gagawin ni water? Magka-climb siya patungo sa gilid ng glass, no? Aakyat siya papunta sa gilid, no? So, as it climbs up, what happens is that it forms the concave meniscus, no? So, umaakyat yung water sa gilid ng glass, no? And yun ay because it wants to maximize the intermolecular force, no? Gusto niya i-maximize yung chance na magkasama sila. So, it will form a concave meniscus, no? Okay? Ang tawag sa phenomena na ito, ang tawag sa force na meron dyan ay adhesive forces, no? Okay, so adhesive forces ang meron dyan, no? From the word itself, adhesive, meaning didikit, no? Yung iyong liquid ay didikit sa other surface, no? So, adhesive force yun. Okay? Bakit may adhesive forces? Because of the similar intermolecular force, no? Similar forces of attraction, no? To dipole yan, dipole to. So, okay sila, match sila. So, it will form the concave meniscus by the adhesive forces. Didikit yung liquid sa gilid ng glass, no? So, tignan naman natin yung mercury. Mercury is metallic bond, di ba? This is the strongest bond. Samantalang yung glass, ito ay polar covalent bond, no? Which is the third strongest. So, kumbaga, si mercury, ito yung strongest. Si glass, ito yung third strongest, no? Kung hindi nyo naaalala, dito lang yan, no? Polar covalent bond, third strongest. Okay? So, tignan nyo na lang yung PDF after the class, no? So, anyway, so kumbaga, ito si mercury, siya yung strongest. Ito si glass, siya yung mahina, no? So, sa tingin nyo ba, yung strong ay gusto ay mahina, no? Siyempre ayaw niya, no? Sabi ni Mercury, hindi naman tayo talo, no? So we do not have the same attraction, no? So instead na dumikit siya, hihiwalay siya, no? So for example, ito si Mercury, kunwari flat yan. Tapos ito si glass, no? So, hindi sila parehas ng intermolecular force. So what will Mercury do? So gagawin niya lahat ng pwede niya gawin in order to minimize its interaction with glass, no? So, lalayo siya kay glass. Pero syempre, hindi yan tatalon sa labas ng test tube, ha? Pag nangyari yun, ewan ko na lang. Okay, so to minimize the interaction of mercury to the glass, it will curve upwards, no? As it curve upwards, mayroon tayong convex meniscus, no? So, it curves upwards, so it will not touch the sides of the glass, no? Hanggat maaari gagawin niya yan, no? Ang tawag natin dyan ay cohesive forces, no? Okay? So, nakikita nyo yung difference between adhesive and cohesive. So, kapag adhesive, your liquid is attracted to the glass, no? Attracted siya sa surface. So, kapag attracted siya sa surface ng isang material, it will form the concave meniscus, no? So, aakyat siya papunta sa sides ng material, no? So, aakyat siya. Bakit? In order to maximize the intermolecular forces, no? Match kasi sila. So, gusto niya tumabi. Samantala, if hindi sila match, no? Pag hindi sila talo, it will form a convex meniscus, no? Okay? So, yan. So, lalayo siya sa side ng glass, no? So, that's surface tension, no? So, yan yung bending of water. So, dalawa yung bending of water. Pwedeng concave, pwedeng convex, no? Kapag concave, yan ay adhesive forces, didikit. Kapag yan ay convex, yan ay cohesive forces. With this, you can actually tell if yung thermometer nyo sa bahay ay gawa sa mercury or hindi, no? Kasi before, mercury yung nilalagay sa thermometer, no? But because mercury is toxic, they phase it out, no? Although may nag-exist pa ring mercury thermometers, no? Ngayon kasi ang ginagamit ay alcohol na, no? So, ano yung alcohol? Dipole. So, kailangan, kapag nasa loob ng glass yon, makikita nyo yon as concave meniscus. So, magpo-form siya ng concave meniscus. So, tignan nyo yung thermometer nyo. Kapag may concave meniscus at the end, safe kayo. Pero kapag nakita nyo convex meniscus yan, magpalit na kayo ng thermometer. Kasi mercury ay gumagawa ng convex meniscus sa glass, no? So, mag-ingat kayo sa mga thermometer na may convex meniscus kasi baka mercury yung nasa loob, no? So, gamitin nyo yung mga alcohol-based thermometers, no? May kita nyo yun as concave meniscus sa dulo. Okay? So, yun lang. Saan nyo pa nakikita ito, no? So, sa medical technology, meron tayong tinatawag na capillary tubes, no? Kung hindi kayo familiar, Google natin, capillary tube. So, saan to ginagamit? Sa dugo, no? Ayan yung itsura ng capillary tube, no? So, maliliit silang tube, kaya nga capillary tawag dyan. So, ginagamit to in collecting blood, no? So, for example, ayan, no? So, this is the finger na natusok, no? Ginagamit kayo ng lancet dyan, di ba? Tapos, yung tawag dyan, capillary tube, ididikit doon sa liquid. Then, what will happen is that the blood will go up, no? Aakyat siya papunta sa capillary tube, no? Yung rising of liquid in the tube, that is called the capillary action. Okay? Yung pag-akyat ng tubig ay capillary action. Ito yung question, bakit may capillary action? Because of the adhesive forces. No? Kasi yung ating blood, this is polar. Yung ating glass, alam natin, polar yung glass. So, mag-a-adhere ang blood sa glass. No? So, aakyat yan ng kusa. No? So, yung pag-akyat ng kusa ng liquid papunta sa capillary tube, that's called the capillary action. No? So, aakyat yan ng kusa. Idikit mo lang yan. Makikita mo yan, bigla yung aangat. No? Okay. So, na-experience ko yan. Tapos, nung ginanong ko yan sa daliri ko, sabi ko, wow, amazing. Capillary action. So, yan yung mga intermolecular forces in daily life na. So, yun. So, yun lang naman. Yun sa liquid na. So, ngayon, pupunta na ako sa solids na. But for solids, I want to use this PowerPoint. This is also uploaded sa Canvas ninyo. No? Okay. So, yung solids natin, dalawang uri lang yan. So, we have crystalline solids and we have amorphous solids na. So, ito na yung last, second to the last pala. Ano yung difference? No? For crystalline solids, observe that, sinabi dito, meron silang long-range order. Maayos yung molecules. No? Maayos yung pagkakasalansan nila. No? Maayos yung arrangement. But for amorphous solids, they do not possess that characteristic. No? Wala siyang order. So, bakit? No? Ano meron kung magkaiba sila ng order? Ganito lang. No? Whenever your crystal structure, no, whenever your solid have a good order, no, long range order, ibig sabihin nun, the intermolecular forces are maximized, no. Maximized yung arrangement, no. So imagine nyo lang yan na for example, apples, no. You will stack the apples or the oranges, no. Nakikita nyo sa palengke, 'di ba naka-stack sila ng maayos. Ano mapapansin nyo? If they are stacked well, maganda tignan yung pyramid ng orange, 'di ba? Matibay yung structure. Pero try mo hindi ayusin yung arrangement, no. Pare, kalat-kalat mo lang ilagay yung orange. Sa tingin niyo mabubuo yung pyramid ng orange? Hindi siya mabubuo, no. So ganun din sa solids, no. When the solids are properly arranged, no, you will form a crystalline solid, no. So maganda yung arrangement dito. And matibay ito. So these are the solids that are strong, no? Ano example niyan? Yung glasses natin, no? Especially yung mga Corning Gorilla Glass in our cellphone devices or yung mga nasa Rolex natin, no? Yung quartz, no? So matibay na uri ng glass 'yon. Ihulog mo man yung quartz na glass, no? Hindi agad siya mababasag, no? Depende na lang sa height, no? Siyempre kapag hinulog mo 'yan sa taas ng building, masisira talaga yung glass, no? Pero kunwari, mababa lang yung height, no? So hindi agad siya nababasag, no? Parang sa cellphone, no? Hindi agad nababasag yung glass ng cellphone unless super taas na 'yan, no? So anyway, so crystalline solids are the solids in which you will see an order sa kanilang atoms, no? Yung atoms are well arrange, no? Parang mga dalandan sa palengke. Maganda yung pagkakapatong nila. So, strong yung kanilang material. However, if the solid, no, yung particles niya ay hindi arranged well, then you have an amorphous solids, no? So, ano meron sa amorphous solid? Ito yung mga marurupok, no? An example ng marurupok, no? Bukod sa friend nyo, yung chalk, no? So, yung chalk, pisilin nyo lang yung chalk, masisira agad, no? Ano pa example ng solid na marupok? Um, baby powder. Solid yon pero powder form. Hindi siya buo, no? Bakit, no? Kasi yung mga particles doon ay hindi naka-arrange na maayos, no? What else? O, yung sa babae, yung makeup nyo, di ba? Yung makeup nyo, scratch nyo lang onte, 'di ba? Nasisira agad yung powder and nasisira agad yung makeup nyo, 'di ba? Tusukin nyo lang sa gilid, dudurog agad eh. So yun ay mga example of amorphous solids, no? Sila yung mga marurupok because they do not possess well-defined arrangement, no? Or hindi sila naka-order. So ibig sabihin nun, mababa yung intermolecular forces nila. So hindi sila matibay, no? So, ano po yung itsura ng crystalline solids? So, papakita ko yung mga itsura ng crystalline solids, no? So, ganito yung mga itsura ng crystalline solids, no? So, what you can see is that the particles are well arranged, no? So, naka-arrange sila kung saan sila dapat, no? So, may pattern kayong makikita, no? Ayan, so naka-pattern sila. Of course, di natin ito i-discuss ng matindi kasi maraming math dito, no? Okay. So yan, mapapansin nyo lang na naka-arrange sila accordingly. Ito yung mga math na ayaw ko ipagawa sa inyo. Yan, bulaga. No? So wag na tayo magganyan. So ito pa yung iba't ibang uri ng crystalline solids. No? So yan, nakapatong-patong sila ng maayos. Parang dalandan, no? So ayan. Okay, so those are the crystalline solids. The particles are well arranged, no? Well packed, no? Maayos yung pagkakapatong-patong nila. So that means matibay sila, no? Pero kapag yan ay amorphous solid, yan ay hindi matibay, no? So for example, yung glass, no? Yung glass, dalawang uri yan. May matibay na glass, crystalline glass. Merong hindi matibay na glass, yung non-crystalline glass, no? So, na example niya, no? So, itong quartz, ito yung mga ginagamit sa ating mga cellphones, sa mga relo, na hindi agad nababasag, no? Itong non-crystalline na glass, ito yung mga nasa bintana natin, no? So, yung bintana natin, hampasin mo yan ng let's say, martilyo. Basag agad yan. Pero yung quartz, no? Yung mga crystalline quartz, hampasin mo man yan ng martilyo, hindi agad yan nasisira, no? But I do not recommend you to do that at home. Baka pagalitan kayo sa bahay nyo, no? So, maniwala na lang kayo sa akin kasi nagawa ko na yan. So, yan. So, kapag yung bintana, hampasin mo ng martilyo, magka-crack agad yan. But yung nasa relo, hampasin mo ng martilyo, hindi agad yan masisira, no? But again, please do not do it at home, okay? Ako na yung gumawa para sa inyo. Okay, so yun yung amorphous, no? So, let's go back to tawag dito, to crystalline solids. May iba't ibang uri ng crystalline solids, na. So the first type of crystalline solid is the ionic crystals, no? Ionic crystalline solids, no? So ano meron diyan? From the word itself, you have ions, no? So yung particles mo ay ions, no? So may positive, may negative, no? Ano example ng ionic crystal? Yung asin sa bahay, no? Yung salt. Tignan mo yung salt, no? Kuha ka ng isang particle na, naka-cube yun. Kasi ganito itsura nila, no? Naka-cube talaga yung particles doon. Okay, so at each end, may mga ions doon. Sa loob, may ions din doon, no? So that's for ionic crystals, no? So you have ions in the solid structure. The next type of crystal is the covalent crystals, no? So, ano meron dito? Instead of ions, you have atoms na walang charge. So, basically, atoms lang. So, ano yung example of covalent crystals, no? So, you have diamonds, graphite, no? Example ng graphite would be your pencil, no? So, matibay-tibay din naman yung pencil, depende sa dami ng carbon doon, no? Depending on the graphite there. One example of strong na graphite ay yung carbon fiber. yung kulay itim na. Yung carbon fiber, that is a covalent crystal, no? So, yung carbons doon, maayos yung arrangement niya in a crystalline form, no? So, solid yon and matibay, no? Stronger than steel pa nga daw, sabi nila. Okay? The next type of crystal is the molecular crystal. So, kanina, yung ating ionic crystal ay may ions. Ang ating covalent crystal ay may atoms. Ang molecular crystal, sila ay may molecules. No? So, one good example here is yung water, yung ice. No? So, yung ice, that is a solid composed of water molecules lang. No? So, ang tendency nila ay mababa lang ang kanilang strength. No? So, masarap nguyain sila. No? Bilang ngumunguya ng yellow. So, yan. So, malambot lang sila as compared to covalent and crystalline ionic crystals na. The last type of crystals would be the metallic crystals na. So, ito naman may mga metal atoms na. Okay? So, yan. So, ito yung pinakamatibay of all na. Okay? So, again, let's summarize all the types of crystals that we have na. So, we have ionic crystals, covalent crystals, molecular crystals, and metallic crystals na. So, for ionic crystals, we have ions. For covalent, we have atoms. For molecular, we have molecules. And for metallic, we have metal atoms. No? So, yun yung mga composition nila. And these are the corresponding forces of attraction that you can find sa kanila. No? So, yan. So, read nyo na lang yan. This is on the PowerPoint naman. No? Na in-upload ko rin sa Canvas discussion. So, download nyo na lang yung PowerPoints doon. Makikita nyo to sa slide 37. So, anyway, so yun lang yung mga crystals natin. So, tapos na yung tatlong agenda natin. So, tapos na po tayo sa forces of attraction, tapos na tayo sa liquids, tapos na tayo sa solids. Ang last one natin would be the phase changes. Okay, so ito yung phase changes natin. Balik ulit tayo sa pinakaunang topic na. Bakit uli may phase changes? Because when you change the temperature, when you change the energy, nagbabago yung phase ng matter, no? So as you increase the temperature, as you increase the energy of your particles, they will separate, no? From solid to liquid, liquid to gas. Pwede rin namang from solid to gas, no? And if you remove that energy from the atoms, binawasan mo sila ng energy, what will happen is that they will come together. Magsasama-sama sila. So from gas, magiging liquid sila or magiging solid sila or pwede naman from gas to solid. No? So for every phase changes, there is a corresponding term. No? From solid to liquid, that's melting. Liquid to gas, that's vaporization. From gas to liquid, that's condensation. Liquid to solid, that's freezing. Solid to gas, that's sublimation. And gas to solid ay deposition. Again, the reason why we have phase changes is that we are adding or removing energy from the matter. No? So the more energy you provide to your matter, the more separate they will be. No? So pag mas hiwalay sila sa isa't isa, then you will expect solids turn into liquid then gases. No? Pero kapag yung energy nila binawasan mo, if you remove that energy from your matter, then you will expect that yung gases natin magiging liquid or yung liquid natin magiging solids. No? So ganun yung process of phase changes. No? So the different phases of matter can be observed with a phase diagram. No? In a phase diagram. So what is a phase diagram? So this is a summary of the conditions at which your substance exists as solid, liquid, or gas. Now. So you have your pressure and temperature axis here. No? So at different pressures and at different temperatures, yung iyong matter would be in different phases. No? So let's consider this, 1 atmosphere. Andito tayo ngayon. No? So at 0 degrees, you will observe may line dito, no? So tumatama ka dyan sa line na yan. This line is called the melting curve, no? So yung melting curve, that is the separation of solid and liquid, no? So ang process from solid to liquid ay melting, kaya melting curve tawag dyan. So if you decrease the temperature, at 1 atmosphere, you will expect that water is solid all the time, no? Pero try increasing the temperature. What will happen to your solid? So as you increase the temperature, as you increase the x-axis, you will pass through the melting point or the melting curve. Then magiging liquid na yan, no? So if you further increase the temperature, you will experience another curve which is called the vaporization curve now. The curve that separates liquids and vapors, no? Or the gas. No? Further increasing the temperature, may vapor ka na. Magiging gas na yung water mo. No? So ganun lang yung pagbasa dito. No? So you select a temperature, you select a pressure, then at different pressure, may iba't ibang phases of matter ka. No? Every time you pass through a curve, may phase change na nangyayari. So if you pass through this, meron kang melting process. If you pass through this line, you have a vaporization process. Pag dito naman sa baba, yung line na nagsiseparate sa solid and vapor, you have the sublimation curve, no? So, kunwari, nandito ka, biglang nag-pass through ka doon. So, yung solid na yellow mo, magiging gas agad, no? So, hindi siya magiging liquid, diretso gas agad siya at that pressure, no? So, yan. So, ano pa yung mga characteristic ng phase diagram, no? So, we can see here, meron tayong intersection of all the curves, no? The melting curve, the vapor curve, and the um, sublimation curve. No? So, nagmi-meet sila at one point. Ang tawag sa point na yon ay triple point. No? So, ano meron sa triple point? No? Triple point is the point at which all phases of matter can be observed. No? So, makita nyo yung water dyan as solid, liquid, and gas at the same time. Okay? So, yan yung ang tawag dyan, triple point. No? Sa lahat ng matter, lahat ng phases niya, makikita mo dyan at triple point. No? Mamaya manunood tayo bago natin tapusin to. Okay? So yan. So triple point ito. Diyan mo makikita lahat ng phases ng matter. No? So anywhere there, isang phase lang yan or dalawa. No? So isang phase lang kapag nandito ka sa curve na to, nandito ka sa loob niyan at nandito. Dalawang phases kapag nasa line ka, tatlong phases kapag nandito ka sa intersection. No? Okay, so iba-iba yung phase diagram depending on the matter. No? For example, we have carbon dioxide, iba yung itsura niya. So at 1 atmosphere, if you increase the temperature, yung solid na carbon dioxide in the form of dry ice, magiging gas agad. No? Kaya yung dry ice nag-evaporate agad, di ba? So hindi siya, nagsasublime agad. No? Hindi siya naging liquid muna. Diretso gas siya. Okay? Pero may chance po ba na maging liquid yung carbon dioxide? Yes, no. So according to the phase diagram, just increase the pressure, you will expect liquid carbon dioxide, no. Okay? So may isa pang point diyan, no, na wala diyan sa mga picture natin. Teka lang. Okay, so ito. So ito yung triple point, no? This is the intersection of melting curve, sublimation curve, and vaporization curve. At the end of the vaporization curve, you will have the critical point, no? So ano po yung critical point? That is the point at which your vapor and the liquid phase can be last observed, no? So yung meaning lang nun, yan na yung point kung saan makikita mo yung liquid and gases as separate entity. Magkahiwalay na sila dyan. Pero kapag lumagpas ka dyan, mawawala yung boundary na yon. Magiging supercritical fluid sila. So ano po meron kapag supercritical fluid? Yung iyong matter will exist as liquid and gas at the same time. No? So hindi mo na makikita yung boundary ng liquid and gas. No? For example, sa baso. Di ba yung baso nakikita mo, yung liquid nasa baba, yung gas nasa taas. Di ba? So, if you reach the supercritical point, no, pag lumabas ka dito sa critical point, pag naging supercritical na yung fluid mo, hindi mo na makikita yung separation of liquids and gases, no. Okay? So, to conclude this lesson, so gusto ko manood lang muna tayo ng dalawang YouTube videos further showing the phases of matter, no? Para mas ma-appreciate natin. So, Google ko lang, ha? Wait lang. Ayan. So yan, ito na yung last part natin, no? So, hanapin ko lang. Saan kaya yan? Ayun. Triple point. Okay. So, so for the final part of our discussion, YouTube lang tayo, no? So, dalawang videos lang to. So, I hope na ma-observe nyo, no? Kahit wala tayong experiments, no? Makita nyo yung mga phase changes, no? Okay, hindi rin naman kasi natin magagawa to sa FEU because, medyo specific yung mga materials na kailangan dito, no? Wala siya sa chemistry lab, more on sa physics lab, no? But anyway, so panoorin natin. I don't know if may napapakinggan kayong audio, pero wait lang. Try ko nga i-check. So, panoorin na lang natin tong dalawang video. Turn on ko lang yung audio. Okay. Ayan. So, what will you see dito sa video, yung triple point. Ano uli yung triple point? Yun yung point at which your solids, liquids, and gases will exist all at the same time. No? Magkikita mo yung tatlong persona ng matter natin. Tapos, mamaya ay yung critical point na. So, yung critical point naman, makita nyo yung liquid and gases, magmimix sila eventually. Mawawala yung boundary nila. No? So, this first video is about the triple point na. Okay? So, nood na po tayo.
Imagine the same substance existing as a solid, a liquid, and a gas, all at the same time. Sounds impossible, doesn't it? It's what's known as the triple point, and we are going to demonstrate it now. Any pure substance can exist in three phases. It can be a solid, a liquid, or a gas. We can show these phases using a pressure-temperature diagram called a PT diagram. This graph shows the location of the different phases of a pure substance in relation to pressure and temperature, with pressure P on the vertical axis and the temperature T on the horizontal axis. The three phases are separated from each other by so-called separation lines. There's a melting line between the solid and the liquid phase, a sublimation line between the solid and the gaseous phase, and the vaporization line between the liquid and the gaseous phase. The triple point is the location where all of these lines meet. It is specified by a certain pressure and temperature that is characteristic for each substance. If a pure substance is at these specified temperature and pressure values, all three phases will be present at the same time. One says that the three phases coexist. Pure water has a triple point temperature of 0.01 degrees Celsius and a triple point pressure of 611.5 Pascal. This is the same as about 0.6% of the usual atmospheric pressure. At this point, water will exist both as ice, as liquid, and as vapor. Let's see what this looks like in practice. For this experiment, we need a vacuum chamber which is connected to a vacuum pump. A combined pressure and temperature sensor is connected to the hose between chamber and pump. It is also connected to a PC via USB, and values of absolute pressure and temperature in degrees Celsius can be shown on the screen. Inside the chamber, we place a Petri dish with liquid water. After the chamber has been sealed, the pump is switched on. Both pressure and temperature start decreasing immediately. During evacuation, the liquid water starts to boil as the pressure drops to the saturation pressure at the given temperature. The glass beads reduce the splashing of water during boiling while the pressure decreases. They will also provide nucleation sites for the other two phases. While the pressure drops quite quickly, it takes longer for the temperature to approach values around 0.01 degrees Celsius. Unfortunately, our pressure sensor cannot measure below 1.2 kilopascal, but we will see later that the pressure is low enough as the water will be in all three phases. This can, however, take a few minutes. After some time, we see both formation of ice on the surface of the liquid water and that vapor bubbles appear in the liquid. We now have a situation where the water is boiling under a thick layer of ice. This is water at its triple point. All three phases coexist. The different phases are, however, not in equilibrium, as the amount of water in each of the phases changes with time. When we switch off the pump, the water will be stable at the triple point as long as the chamber manages to hold the necessary pressure and temperature conditions. Once we open the inlet valve and increase the pressure back to normal, we can see that the vapor bubbles disappear first. Small droplets on the glass bell eventually evaporate and the ice in the petri dish begins to melt. In a second run of the experiment, we also place a small beaker with sulfuric acid in the chamber. The acid attracts water molecules from the gas phase and helps to improve the vacuum.
Okay, so what
The steam produced during boiling eventually lifts the ice cap in a sudden motion.
Okay.
The triple point of water is used to define the Kelvin scale. Kelvin is the unit for absolute temperature in thermodynamics and one of the 7 base units in the International System of Units. At absolute pressure below the triple point, a substance cannot exist in its liquid phase. During condensation, for example, it will go directly from the vapor phase to the solid phase. This process is called deposition. We can observe this effect in nature. Fern frost can form on solid surfaces by the direct deposition of water molecules when the surrounding air is at temperatures below 0 degrees Celsius.
So anyway, so ano nakita natin na that at triple point you will observe that your
As the amount of
matter exists as solid, liquid, and gas at the same time. No? So may certain proportion lang ng temperature and pressure to meet that triple point. No? So yun lang. So the next video is focused on the critical point naman. So the critical point is the point at which your liquids and gases can be last observed. No? So doon mo na makikita yung last point where liquids and gases are separated. So if you reach any temperature or pressure beyond the critical point, you will observe a supercritical fluid. Na. So ano yung supercritical fluid? That is a state of matter na magkahalo yung properties of liquids and gas. So wala kang makikitang phase boundary. So let's watch that. No?
Every substance
Teka lang. Taasan ko lang quality. Ay, naka 1080p na. Ay. Ayan.
Every substance has a critical temperature and a critical pressure. When a substance is subjected to temperature and pressure that both exceed these critical values, it enters what is called a supercritical state. Any pure substance can exist in 3 phases, can be a solid, a liquid, or a gas. We can show these phases using a temperature-pressure diagram called the PT diagram. This graph shows the location of the different phases of a pure substance in relation to pressure and temperature, with pressure P on the vertical axis and the temperature T on the horizontal axis. The 3 phases are separated from each other by so-called separation lines. we have the sublimation line, which divides the solid and the vapor phase. The sublimation line ends at the triple point, which is the point where all three phases coexist. There is a melting line between the solid and the liquid phase, and the vaporization line between the liquid and the gaseous phase. The ends in the critical point. The temperature on this point is called the critical temperature and usually gets designated the symbol TCR. The critical pressure has the symbol PCR. These values, together with the critical density, are characteristic for each substance. With pressure and temperature that exceed the critical values, the substance will become supercritical and the differences between the liquid and the gas phase disappear. Let's see how this works in practice. For this experiment, we made our own pressure tank. It has a thermometer, a pressure meter, and a pressure relief valve. We also have some dry ice, which is carbon dioxide in the solid phase, a heating plate, and a heating base. We put some dry ice into the tank and seal the tank. As the pressure tank is completely sealed, the pressure builds. The dry ice starts at a low temperature, but with the rising pressure, it soon turns into a saturated liquid vapor mixture at about 40 bar and 5 degrees Celsius. By applying heat to the tank, we increase the pressure and temperature towards the critical point at constant volume. CO2 has a critical temperature of 31.25 degrees Celsius and a critical absolute pressure of 73.9 bar. So we want to heat up the carbon dioxide to its critical temperature, and because the volume of the tank is constant, we can also build up the pressure. As the pressure and temperature reach the critical point, the distinction between the liquid and gaseous carbon dioxide becomes less visible and eventually disappears. The phase boundary between the liquid and the gas vanishes. The CO2 is now in a supercritical state.
Okay, so ano yung napansin nyo? So before reaching the supercritical state, you can see here the liquid carbon dioxide. Above it is the gaseous phase. No? However, if you further increase the temperature and pressure, reaching the point of the supercritical liquid, no? Pag lumagpas na siya sa critical point, ano yung napansin nyo? No? So ganito yung nangyayari. No? So naghahalo na yung kanilang itsura. So this is the last point na makikita mo yung boundary. Then eventually, magmi-mix na lang sila.
The phase boundary between the liquid and the gas vanishes. The CO2 is now in a supercritical state.
Okay, so wala na yung ano,
To
no?
return,
Wala na yung liquid and gas na distinction. No? If you want to separate liquid, the supercritical fluid into liquids and gases, all you have to do is to decrease the temperature and the pressure. No?
to a state below the critical point, we will cool the carbon dioxide and make it reappear in the saturated liquid vapor mixture.
Okay, so papabalikin nila yung separation.
By removing the heating plate and then adding dry ice on the aluminum cylinder, we can observe that the liquid vapor interface suddenly reappears as the temperature decreases.
Ayun, so bumalik na siya, no?
We have returned to the saturated liquid vapor mixture. Supercritical CO2 is used in a variety of applications, for example, to remove caffeine from coffee beans.
Okay, so yun lang naman yung concept niya, no? You can check that on YouTube. Type mo lang critical point and triple point, yung video ng Medilab HVL. So yan. And maraming other videos on YouTube as well. Okay, so that's the end of the chapter 5 discussion. Okay, so na-discuss na natin yung solids, liquids, and yung phases of matter and the forces of attraction. No? So all the materials are uploaded in Canvas. Download nyo na lang. Just go here. Medyo binibilisan ko na lang kasi tapos na tayo. Baka may class pa kayo mamaya eh. So just go to discussions, then punta kayo sa chapter 5, section 21. So all the materials uploaded here are used no sa lesson na to. Ito yung ginamit ko pala. Specifically, itong chapter 11 IMF Intermolecular Force and itong chapter 9 no PDF no. So yan. So itong dalawa yung ginamit ko for this lesson. No? Although you can read the other PDFs as well para may additional materials kayo no. So kumbaga more on concept lang talaga itong topic na to. So walang problem solving. Okay? So that's all for the lecture part ng inorganic chemistry section. No? So ito, tapos na po tayo sa inorganic class natin. Next lesson natin after the examination would be the organic part naman. No? So tapos na tayo sa inorganic. I hope na you use the OWL V2 materials or yung other materials natin such as mga PowerPoints no and yung previous quizzes natin para makapag-review kayo no. So also another way for you to review is to binge watch yung ating YouTube channel no. So just go to Canvas, punta kayo ng announcements no. And alas na to. Just go to Canvas, punta kayo ng announcement, then check nyo yung YouTube videos natin. And para makapag-review kayo. Okay? So with that, I thank you for your attendance and I'll see you again next time kasi next week ay quiz nyo. So all the best. If you have any questions, just drop by my inbox dito sa Teams or sa Canvas. Okay, so the recording of this